Hey there, this is Math 7, Unit 5, Lesson 14, solving problems with rational numbers. And so we're going to use all four operations today with signed numbers to solve some various problems. Let's take a look first of all at our draining and filling a tank again. Okay. So it says tank of water is being drained. Due to a problem, the sensor doesn't start working though until some time in the draining process. The sensor starts its recording at time 0 when there are 770 liters in the tank. Given the drain empties at a constant rate of 14 liters per minute, now again we're draining, so that's a negative 14 liters per minute, complete the table. So we can see it's already set up for us, so time after here, at the start it's at 770, that's where it began, and because it's at 0 we multiply that by the rate, that's our K value, okay? And this value here tells us how much we're losing at each minute, right? So in the first minute we lose 14 liters. So 1 times negative 14 tells us our change at negative 14. And so this becomes, the solution here becomes the starting value, taking away from that the negative 14. So if the change here is negative 70, for 5 minutes we do our initial start point, we multiply that and we add that to times a negative 14. So our rate for 5 hours. And 5 times a negative 14 is that value of negative 70. So again, we're subtracting that not from 756, but from the original. So 770 minus 700 is actually equal to 700 here. And here, we do 770 plus 10 times negative 140. And 10 times negative 140 is negative 140. So that's the change, is negative 140 from the original. So 770 minus 140 is actually equal to 630. Okay? So just a way of setting up the expression a little differently here, right? Where you have the initial amount and you're adding to that the change. And the change is going to be the rate times the number of hours or minutes in this case here that it's gone on for. Later, someone wants to use the data to find out how long the tank had been draining before the sensor started. So we're going to complete the table here with some more values here. Now notice that the values in this case here, the sensor came on at 0, and we would before did the value there at a positive minute, right? So this is going the opposite direction. So this is the number of minutes before the sensor, right? This is all time before. So we're writing the time before as a negative time value there. And this is going to allow us to increase the amount of water for each minute that we do. So for negative 2 minutes before the sensor, it'd be 770 plus negative 2 times the negative 14. Negative 2 times the negative 14 has a value of positive 28. So 770 plus 28 is going to be 798. Okay? Now thinking about this just from the standpoint of what we're doing, we're adding 19 liters in the tank every minute. So when I look at 3, if I go 3 minutes to 4, if I add 14 liters here, I'm going to end up with, carrying there, 812. When I add 14 to the 4, I'm going to have 826. When I add 14 there, I'm going to have 840. So it's adding 14 liters, right, every time is what I'm doing. So my equation, though, is 770 plus, in this case here, negative 3 times negative 14. Negative 3 times negative 14 is a total of 42. 770 plus negative 4 times negative 14. Negative 4 times negative 14 is 56. And then 770 plus negative 5 times negative 14. Well, again, I could also think, what is 14 more than that? That's going to be 70. So if the sensor started working 15 minutes into the tank draining, how much water was in the tank to begin with? Okay, so that means it started working 15 minutes. It had already gone 15 minutes before it had gone off. Okay, so it had been draining for 15 minutes. We want to find out what it was, how much water was there before. So we take the value of the water we had at 0, which was 770, and we're going to add that then to 15 minutes before times our rate of 14, right? So negative 15 times the negative 14 is 210, which tells me 770 plus 210 means there were 980 liters of water in the tank before it started to drain. All right, let's take a look at the next one. Utility company charges 12 cents per kilowatt hour for energy a customer uses. They give a credit of 2.5 cents for every kilowatt hour of electricity a customer's solar panel generates. So we have a charge for what you use and a credit for what you generate. A customer has a charge of $82.04 and a credit of $4.10 on this month. What is the amount that's due? The amount that's due is going to be the difference between those two values. So we can do $82.04 and we subtract $4.10. Okay? We can think about it as a difference. We can also consider it as 82.04 and add to that a credit of negative 410. Right? So you can set up that way. You still end up with 82 minus 4. So however you want to think about it, this is what you end up doing. So 4 minus 0 is 4. We borrow here, 10 minus 1 is 9, bring down the decimal. We borrow here, 11 minus 4 is 7. So we have $77.94 is what is due. How many kilowatt hours did they use? Okay, well, to find kilowatt hours, we take the charge, $82 is what they were charged, all right, for the kilowatt hours, and we divide that by the rate, which was 12 cents per kilowatt hour. So we're going to find out how many of this was inside of that, and that gets us about 683.66, or if I want to round that up, we would say about 684 kilowatt hours. In terms of how much did they generate, we know that they made $4.10 on their credit, so we'll divide that by the rate that they get that at, which is 0.025. So 410 divided by 0.025 is about 164 kilowatt hours is what they generated with their solar panels. All right, let's take a look at today's homework. All right, a furniture store pays wholesale price for a mattress. Then the store marks up the retail price to 150% of the wholesale price. Later, they put the mattress on sale for 50% off the retail price. And a customer just bought the mattress on sale and paid $1,200. What was the retail price of the mattress before the discount, and what was the wholesale price? So we're going to have to work backwards here a little bit, right? We know that they bought it for $1,200. Now, they got it for $1,200, which was on sale for 50% off the retail price. Let's take a look at that first of all. If you had the price of the mattress, right, we can call that X, or we can call that the retail price. Let's do this like this. If we did the retail price, so if we did the retail price and you multiply that by 50%, right, 0.5, 50%, this will give you half of the retail price. Now in our case, we know that half of the retail price, 50% of the retail price, was going to be $1,200. That's what the customer paid. So to find the retail price then, I divide both sides by 0.50, and so my retail price is going to be equal to 1,200 divided by 0.5, which in this case is $2,400. That's my retail price. Now, in terms of the wholesale price, we know that the wholesale price is going to be the wholesale, right, is 100% of the value of it, plus they did a markup of 150%. So we're going to do 100%, and then we're going to add that to, with 100%, we're going to multiply that by 150%. That's going to be 1.5. Now the wholesale price times 1.5, 150%, is going to be equal to the retail price, which was $2,400. So to find the wholesale, we're going to divide everything by 1.5, so that our wholesale price is $2,400 divided by 1.5, which is $1,600. So that means that the customer who bought it for $1,200 got a good deal in terms of the retail, but the company itself, they bought it for $16. They're still making a profit, right? They're still making a profit of $400 because they're not, they're losing money. They bought it for $1,600 and they sell it for $1,200, losing some money there. Okay, all right, let's move on. Table shows transactions in a checking account in January, February, March, and April. Find the total of transactions for each month. So what you want to do to find the total is you want to find the sum for each month. You're going to add together the -38, 126, 429, -265. When you do that, you come up here with 252.20. Here you come up with $88. Here you end up with $1.70, and here you have -$836.90. Find the mean total for the 4 months. So the mean total is going to be to add January plus February plus March plus April, add those totals together, and we're going to divide by the number of months we're looking at, which is 4, because the mean stands for the average. So when you divide the sum of these things together, divided by 4, you can show your work here, you should come up with -$123.75. I really don't have any work showing here, I'm just getting you the solution, the setup. You need to show your work for what that sum would be. That's the key thing there. So add those values together. Oops, don't put a negative there. Add those values together and see what you come up with, and divide by 4, and you should get there. All right, bank charges a service fee of $7.50 per month for a checking account. A bank account has $85. If no money is deposited or withdrawn except the service charge, how many months until the account balance is negative? All right, so we're looking at this. You have $85 is what you have, and we're going to subtract from that the fee of 7.5 times a certain number of months. We want to see kind of when do you get down to having no money? When does that equal 0? Because once you go past that, you'll be at a negative value. So we're going to do -7.5x equals 85. We'll divide both sides by -7.5 so that x equals, in our case here, 11.3. So at 11.3 you're at 0, which means that on month 12 you're going to be in the negative zone. Okay? So you can get 11.3 months and then you run out of money, and after that you're in trouble. So you end up with 12 months is when you're out of money. Let's look at number 4. A large aquarium is being filled with a hose. Due to a problem, the sensor does not start working until sometime into the filling process. The sensor starts its recording at the time 0 minutes. The sensor initially detects the tank has 225 liters of water in it. So at time 0, we're at 225. The hose fills the aquarium at a constant rate of 15 liters per minute. What will the sensor read at the time 5 minutes? Okay, so we take the amount that we have, 225, and we're going to add to that our rate, or well, we're going to do our 5 minutes, and we're going to do that 15 liters a minute for 5 minutes. So we know we're at 225, and we're going to add to that the amount that we increase for those 5 extra minutes. So 225 plus 5 times 15 is 75, and so 225 plus 75 is 300. So we're going to have 300 liters in the tank after 5 minutes. Later, someone wants to use data to find the amount of water at times before the sensor started. What should the sensor have read at -7 minutes? So it's the same idea, same setup. We'll do the 225 for what it was at 0, and we're going to add to that the -7 times the 15. -7 times 15, yep, 15. So that's going to be 225 minus 105, which is going to equal 120. So 7 minutes before the sensor went off, there was about 120 liters of water in the aquarium. All right, number 5. A restaurant bill is $21. You leave a 15% tip. How much did you pay including the tip? Okay, so to do that here, we're going to do $21 and we're going to multiply that by our tip amount. So 15% written as a decimal, move it over 2 spaces, becomes 0.15. Okay, and 21 times 0.15 is equal to $3.15. And now I need to add that back to my bill, which was 21, and you end up with $24.15. That's one way of doing it. Another way of looking at it would be that your bill is going to be $21, right? You're going to pay 100% of the bill, plus you're going to pay 15% of the bill, right? So there's my 21, there's my 100%, which is 1. And so when I combine these together, I have 1.15 for 115% times 21. When I multiply that out, I still end up with $24.15. So both methods work. Either you find the tip and then add it back to your subtotal, or you combine the tip and the 100% of the bill and multiply it by your subtotal to get the same value. So which of the following represents the amount of money a customer pays, including the tip of 15%? All right, so which one matches here? 0.15 times the bill, that is just going to be the tax itself, or the tip itself, not quite enough. 15 times the bill, that's just crazy talk. Over here, this is our 1, it's 100% of the bill plus 15%, which matches right here, right? 100 of the bill plus 15, so C would work. 115, or 1.15 times the bill, D would work there. Not sure what that is, that's a decimal problem, not going to work. And then here, this one looks different, right? But B is still 100%, and 15 over 100 is the same as 0.15. So the F is just checking to see, do you know that that is the same as 0.15? And that one's not going to work. Okay, that's it for the day, and we'll see you next time.